IBM of International Business Machines Corporation is a worldwide symbol of pioneering and leadership in the conception, design, and production of such machines. One of the major plants of this great industrial enterprise is located in the Hudson River Valley at Poughkeepsie, New York. Here, research, product development, and production engineering today are applying the most advanced findings of electronics investigation to making machines whose operations simplify the most involved of accounting procedures and resolve the most challenging of data processing problems. This is typical of the large-scale systems IBM is producing for the processing of data relating to every avenue of human experience and action. The astonishing capabilities of these machines are built about magnetic memory cores which store both data and processing instructions. Results are computed and decisions are rendered in millionths of a single second. Fabrication and assembly of the scores of thousands of parts which make up a single IBM electronic accounting or data processing machine are mapped and guided from beginning to end by the distribution of a huge volume of engineering drawings. Haloid believes it to be significant that IBM, whose own efforts for more than 40 years have been identified with simplifying the complexities of paperwork, today is using combined xerographic copying and offset duplicating procedures as more efficient and economical methods of delivering this vital paperwork in time to meet manufacturing program demands. When the original drawing has been finished, it is taken directly to the product engineering duplicating section to be copied by Xerography. The xerographic and offset procedure requires but a single handling of the drawing, that in which it is mounted on the copy board of the Haloid Robertson Model 1218 camera for exposure. Because the xerographic copying process reproduces pencil detail with a fully satisfactory degree of readability, no costly, time-consuming inking of the drawing is required. While the copyboard operator and his co-worker in the dark room at the rear of the camera carry out preliminaries to exposure of the Xerox 1218 plate to the drawing, let's consider other features of the IBM drawings duplication procedure. In the copying of C and D-sized flat drawings onto the 12 by 18-inch plate, the reproduction is scaled down to 11 by 17 inches, or to 46 to 61% of the original size. IBM has discovered that by requiring standard-sized, open-faced lettering and figure detail in the drafting of drawings, no readability is sacrificed in using reduced reproductions. These save material costs, conserve filing space, and handle with more ease and convenience than size-to-size reproductions. Our next scenes provide a walk-through look at the xerographic copying cycle as carried out at IBM, beginning with sensitizing of the plate and continuing with exposure, plate development, and again outside the darkroom, transfer of the image on the plate to an offset paper master and fusing of the master. Production in a few minutes by Xerography of an offset paper master bearing a reduced photo-exact image of the original drawing is in marked contrast to the drawing duplicating method formerly used by IBM. That method called for the use of size-to-size cloth reproductions of originals. The reproductions were handled constantly with resulting loss of quality as copies were made singly. Slowness of the process caused a pileup of reproductions awaiting use in execution of copy orders. In addition to other methods of reproducing engineering drawings in IBM, Xerography has played an important role in reproducing some of the large quantity of engineering drawings at high speed. In this application alone, the duplicating section of IBM's product engineering department has achieved estimated savings of $65,000 a year by supplanting formerly used methods with the faster, less costly one carried out with the Xerox Model 1218 units and offset process duplicators. After fusing completes the 15 by 20-inch master, it is sent to another duplicating section in manufacturing, where it is held on file until copies are released by order of production control. Total time consumed in making the master and running off the copies represents only a fraction of that formerly required to fill a drawing reproduction order. The runoff of the copies is extended beyond the number needed immediately. The reserve will be kept on file and made available upon requisition to any department requiring extra copies. Made with these extra copies is a vellum transparency, which can be used for diazo reproduction and thus extend the reserve. The advantages of maintaining reserves of copies at a very slight addition to the original order cost is immediately apparent. The advantages are even better realized when the time and cost factors involved in requisitioning extra copies under the formerly used method of reproduction are considered. Development of innovations in the use of xerography to meet particular needs is part of the history of that relatively young but already widely used process. In IBM's product development laboratories, such an innovation has been of incalculable value in dispatching engineering change notices to production lines. Working on the back of reverse-reading sepia intermediate copy of the original, the engineer cross-hatches out that portion of the drawing which is to be removed and boldly draws in the detail of the change. The intermediate now goes to a draftsman who uses it as a guide in making the marked-out deletions from the original drawing and adding the change. Ordinarily, when the original has been altered, both original and intermediate go to the duplicating section to be copied onto offset paper masters. However, when the change is urgent, the nature of the innovation makes possible execution of a change notice by duplicating the intermediate alone. In such cases, the alteration of the original is deferred temporarily. In the xerographic copying procedure, the intermediate is mounted, corrected side up, on the copy board with the effect that the drawing, in exposure, will be copied right reading through the paper. The portion lightly marked out will stand out in faint but readily discernible detail. The change, on the other hand, will take on much bolder relief than that of all the remainder of the drawing. Thus, xerographic and offset-produced copies of the intermediate assume the identity of visual engineering change notices. These notices, when distributed with copies of the altered original, may be read and interpreted immediately without the necessity of studying cumbersome and laboriously prepared engineering change information. If the notice is sped through without an accompanying copy of the altered original, it may as easily be understood by comparing it with an already on-hand copy of the unchanged original. The IBM development of visual engineering change notices and the role played by xerography in shortcutting their copying and distribution have combined to save as much as a week of the time formerly required to get such notices to manufacturing. A close-up look at a visual engineering change notice made with xerography plainly reveals both the bold outlines of the drawn-in change and the fainter ghost image of the deleted portion copied through the paper. While nothing has been completely erased, the change has become visual indeed. Under the procedure previously followed in executing engineering change notices, an intermediate copy of the original was marked up by an engineer and delivered to a change writer. The change writer studied the change and then composed the explanatory information in longhand. After the change writer had finished with the intermediate, it passed to a draftsman who used it as a guide in altering the original. Next, a reproducible cloth copy of the altered original had to be made for use in producing one at a time the required number of copies. Meanwhile, the writer's explanation of the change had to be transcribed by a typist onto an offset paper master, or several paper masters, depending on the bulk of the information. When the copies of the information were run off, and when the copies of the original finally were completed, they were distributed together. Formerly, the department responsible for forwarding change notices was able to process from 10 to 12 daily. The new method, built about the visual engineering change notice and reproduction with xerography, has more than doubled that capacity with accompanying easement rather than aggravation of the workload. The value of the Xerox 1218 unit as a tool for dispatching engineering change notices further is demonstrated by a versatility wherein marked-up intermediates of small drawings may be copied at a 2-up rate. Duplicates of both are run from the single offset paper master. IBM isn't alone among the world-leading American industries which have discovered that xerography represents a time-lapse and cost-cutting key to the solution of paperwork reproduction problems. Among such users is the Chrysler Corporation, whose Highland Park, Michigan plant might be called an architectural counterpart of the forward look its designers have imparted to Chrysler motor cars. Part of the spirit behind the building of Chrysler products is an unslackening search for and application of better methods. That alertness led to Chrysler's first limited use of xerography. Today, Only 3 years later, that initial use has been expanded in variety and multiplied in volume to such proportions that paperwork cost savings realized through xerography are estimated by Chrysler at $250,000 yearly. The duplicates Chrysler runs at the rate of millions annually from offset paper masters produced by xerography include reproductions of engineering drawings, changes in orders, technical reports, manuals, financial and operating statements, office and factory forms, correspondence, dealer bulletins, and press releases. We've just scratched the surface, is the way the Chrysler's forward-looking users of xerography sum up the possibilities for even greater utilization of the process. The arresting beauty of the rotunda graces approaches to the Ford Motor Company's administrative center at Dearborn, Michigan. Here are located the facilities of administrative services that help keep far-flung divisions of this car-producing colossus functioning. Ford has been identified with many firsts in automobile design and manufacture. In the field of xerography, Ford, too, holds credit for a first. Special equipment designed by Haloid to Ford specifications several years ago became the first to speed the reproduction in reduced scale of large-sized engineering drawings, which could not be handled with other Xerox equipment then available. In the duplicating section of the Engineering Staff Administrative Services Department at Dearborn, xerography long since has become one of the standard processes through which the reproduction of engineering drawings has been accelerated. With the xerographic speed-up have come cost savings estimated at $75,000 a year. Ford today uses xerography to make size-to-size drawings up to the dimensions of the 1218 plate, for the scaled-down copying of larger drawings, for the two-up copying of small drawings onto a single master, and for making enlarged copies of small drawings. Operators working a single Xerox installation at Dearborn produce as many as 400 masters a day. Ford also gets part lists into distribution much more rapidly today by copying and duplicating them with the xerographic and offset method. This is the Glenn L. Martin Company of Baltimore, Maryland, pioneer builder of redoubtable aircraft, a leader of experiment and production in the vital-to-defense field of guided missiles, and today, principal contractor for the implementing of America's own attempt to project a man-made satellite into outer space. Martin Aircraft has adopted xerography and Xerox 1218 equipment as an integral part of an improved duplicating system which has reduced material and processing costs by 1/3. The savings realized through the use of xerography as a means of duplicating larger engineering drawings with a 50% reduction in scale, as well as other economies made possible by the process, now amount, according to Martin's estimate, to $60,000 a year. But before accepting xerography, Martin subjected Xerox units to shakedown tests. These tests determined that copying by xerography eliminated the necessity of preparing originals on costly linen or vellum, that xerography could lift legibly sharp black and white copies from soiled or even dog-eared originals, and that copies produced by the all-dry xerographic and offset duplicating procedure held to levels of stability that could not be maintained in the use of other methods. In weighing the advantages of its new copy reproducing procedure, Martin Aircraft has found that xerographically produced drawing copies are made available with sometimes critically important shortening of the reproduction time cycle, that the process eliminates hand shearing of size-to-size copies made by other methods, and the folding and refolding necessary in handling them. Martin Aircraft also employs the combined xerographic offset method for making multiple copies of organization charts, standard process bulletins, Air Force and Navy specifications, and manufacturing division manuals. These comparison scenes demonstrate the bulk savings realized through making black and white reduced copies of drawings by xerography. The smaller copies easily may be compared several at a time without overlapping. Standardizing of drawing copy reduction has whittled down the size of shop order folders and the cost of mailing copies to customers and vendors. Let's take an official view now of the launching of a rocket missile developed by Martin Research and Engineering. The jet propulsion principles which have been harnessed to thrust such missiles through the skies are at this moment being applied to the creation of projectiles capable of intercontinental flight. Such principles, too, will be used in engineering vast power resources with which an attempt will be made to project a man-made satellite into outer space. Whether industrial effort is pointed toward new goals in data processing automation, in automotive advancement, aeronautical evolution, or in any other progressive direction, there is no substitute for the prompt distribution of engineering information carried by drawings and related paperwork. In this connection, xerography is a tool that keeps the pace of achievement speeded toward the last objective.